Hey, Jim, I'm looking at your data set here. So, subject 1953, she got a lot of subjects, I'm noticing. I don't think she has 2,000 of them. So, what I'm seeing here is, you might not be able to see it on this crappy video, is these little tiny dots in empty boxes. That means that SPSS is going to count them as something, even though there's nothing there. So the first thing I'm going to do is get rid of all those dots. Hopefully they're not going on for infinity. Come on. Oh, okay. So right there. The boxes underneath here do not have the dots, but the ones above it do. So I'm going to go ahead and just clear these out. And I'm going to give it a quick test. She has 142. So I'm going to do an analyze descriptives frequency, and it doesn't matter. I'm going to put in any one. And good. So that takes care of the missing problems. That was easy. So just make sure if any cell has a dot or anything in it, or SPSS is going to count it as something real, which is not the case here, but that's been fixed already. Back to our problem. All right, here's the variable view. She has something marked nominal, but she doesn't mark what they are. Let me just check over here. College persistence ones. Oh, okay, she's got some variance in there. 2s and 3s. Okay, all right. I'm just going to run a multiple regression with these number of semesters as the DV. Here we go. Analyze regression linear. So the semesters is our DV. Let me see. Oh, it's all on the screen. And everybody else except for subject, test 1 through 10, are our IVs. And what do we want? We want this, the Durbin-Watson. We want, this will check for some of the assumptions. The assumptions I'm not going to overly worry about, but I just do this. I've been doing it so long. This is like automatic to me. I don't even have to think about it. So Mahalanobis will tell us about any multivariate outliers. Options, I don't think we need anything there. The rest of this stuff is crap. And never ever bootstrap. Bootstrap is for losers. Okay, click OK. And the output says, dun, 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 dun. Here's all the means and standard deviations. We really don't care about what these are in a regression model. And correlation table, we don't care about that right now either. But here's our money box, our model summary. So her R squared is 0.113. Let's see if that's significant or not. And unfortunately, it is not, right? The significant change is the same as the ANOVA down here. The ANOVA tells us if the regression model that she built is significant or not. And unfortunately, it is not. This number has to be less than 0.05. So with that said, we can look around and see what else she's got going on here. So here's all the tests, and we'll just check them out here. None of them will be, well, I take that back. There is one significant here. It's a significant beta weight, and that's the problem. Only one of them is a good predictor. The other ones, like test 2, is not. Test 3 is almost, right? It's a borderline. No, test 4, test 5, test 6. Test 7 could almost be considered borderline, but 8, 9, and 10 are caca. So, and I don't think she violated anything. But what I'm going to do now is I'm going to rerun her test only with those that are significant and almost significant. So test 1, test 3, and 7. 1, 3, 7. 1, 3, 7. Here we go. So analyze regression. Where'd you go? 1, 3, 7 coming up. So we're going to keep 1, going to keep 3, and delete the rest of you guys. Keep 7, 8, 9, 10. So the ones we took out are not significant predictors of the number of semesters. Everything else should be okay. Click OK. And here we go with the big 3. And what have we got going on here? We have an R squared of 0.082. Not the strongest in the world, but it is significant. Well, she does have a significant model with the predictors test 1, test 3, and test 7. She should drop those other ones, but it is significant predicting model here. And out of those 3 tests, we're going to see which one is, they're all significant, yay, yay, yay. The best predictor is test number 1, right? That's what the beta weight says. Don't worry if it's positive or negative, right? We just take the absolute value to see who's the big boy and who's the little boy. So the best predictor of the number of semesters is test 1. In other words, the higher the test 1 scores, the more semesters they would have completed, right? Because it's negative. And test 3 and test 7 are equally the same, right? So whatever they're doing there, they're the same strength. So number 1 predictor of number of semesters is test 1, and number 2 and 3 tied are test 3 and test 7. Real quick, I'm going to go take a look at what question 1 seems to be measuring. So remember, when these numbers go up, the number of semesters goes down because that's what the negative beta weight means. So I'm kind of curious, what exactly is test 1 measuring here? I wonder if they're SAT scores or something. But again, test 1, when that goes up, number of semesters goes down. Test 3, when these numbers go up, the number of semesters go up. And test 7, when these go up, the number of semesters go up. So that's all I can milk out of this thing for now. All right, I hope it helps. MGZ out.